Hey, everybody. Hey, everybody. This is Larry. This is day 7 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Oh, look, I haven't done this poem before, so yay, go Larry. 904, fruit into baskets, medium poem. You're visiting a farm that's a single row of fruits, tree arranged from left to right. Okay, so you have this, and then you want to collect as many fruit as possible. However, there are strict rules. You only have 2 baskets, and each basket can only hold a single type of fruit. There's no limit of amount of fruit each basket can hold. Okay. Starting from any tree of fruit, you may extract one fruit from every tree while moving to the right. The picked fruit must fit into one of your baskets. Once you reach a tree with a fruit that cannot fit into your baskets, you must stop. Okay, return the max that you can fruit. I don't think I understood this at all. Fruit sabaya is the type of fruit that the IF tree can produce. Oh, okay. So this is the type. So then basically here, it's saying that you could put 1 in one basket and 2 in the other basket. Here you can only look at 3. And here, I think this is, there are a lot of frustration going on where they try to make it confusing and maybe hard for you to understand. But I think this is pretty straightforward if you are able to look at it backwards, right? Meaning that, okay, you check to see if this is the first, just one at a time. Is this good? Yes. Is this good? Still 1 fruit. This is good? Yep, 2 fruit. This is good? 3 fruit. And then we stop at 1 because now we need 3 baskets, right? And that's pretty much it, really. And then just return the index. So, okay, so yeah, I'm going to be lazy and just use a set. But we do something like for F in fruits, reverse it. Maybe it could be. I don't know if this is an iterator or not. I always forget which one is an iterator and which one is a thing. But either way, right? Yeah, maybe I could also just do like a count is equal to 0, right? If length of S is equal to 2 and F is not in S, then we return count. And then otherwise S dot F and then just return count afterwards. Oh, well, we have to increment, of course. That's pretty much it, I think. Yeah, all right, let's give it a quick submit. Oh no, wrong answer. I misunderstood the problem. 1, 2, 3. Maybe I didn't how do you get 5 if... Okay, so maybe I just misunderstood this problem. Yeah, I thought you have to pick every fruit, right? So 5 mean these 5. Did I misunderstood this problem? Or is it something like these 5? So it's a substring because you stop. So okay, so I think I misunderstood this problem clearly, which is kind of sad because this isn't that hard of a problem, or at least it's marked as medium, and I haven't done it before. So, but it seems like I misread this. I thought that you have to. I see. So basically, it's saying that you can start at any index. I don't know how this passed 31 cases also, by the way, just like this really wrong algorithm. But okay, so you start with any of this, and then you basically keep on going until it is no longer whatchamacallit, no longer hold by 2 baskets, right? And you could do this by sliding windows. It's really not that difficult, but I think I just misread this one or misunderstood this one. It's late in the day. I actually, in case you're curious, I did go to a basketball game, an NBA game, and it's very late. I'm really tired, but that's my excuse. I'm sticking to it. But yeah, so left is 0 to 0, right? And then for right is in range of n, say, and n is 0 to and basically we could just do a collection of like things that are inside the window that we're sliding on. So basically maybe we just call it let's call it count because I'm really not creative. And then the other thing is that we maybe just I think like best is equal to 0 or something like this, right? Okay, And then basically now we process fruit sub. Right. So we do count of this increment by 1, and then if length of count is greater than or equal to 3, because then we have 3 baskets, then we just parse left, right? So we have this, so we remove this from the thing. So this is a while this is 3, and then if count of, I'm just going to paste this. If this is equal to 0, then we could delete it, and then left we increment, and then and then return best. Of course, at the end of every loop, we try is equal to max of best, or right minus left plus 1. Is left inclusive or not inclusive? Left is not inclusive, so I think it's just this maybe. Maybe I'm off by 1, but it should be okay. I should have copied that test case. Okay, so it is plus 1. Math is hard. Should have copied that 1 case though. Do I still have it? I guess I still have it here. Though I just kind of misread this one, so I don't know. Still not that bad. Okay, so at least it's good for this one. Okay. Cool. Yeah. Sloppy Larry. Sorry, friends, for misreading and misconfusing. But yeah, this is a very typical, very standard sliding window after I've correctly understood this problem. And basically, one thing that I would say, if you this is amortized, let me say, it's just linear time, linear space, but it takes amortized analysis, because for basically the left, this gets incremented n times at most, and right obviously it gets incremented n times, and this loop gets moved left times, right? And left is O of n, so that means you have O of n plus O of n, and therefore it is linear time, linear space. Linear space on the counter, but I guess not actually. I guess counter is really only at most 3 things, so maybe it's constant space actually, so I was wrong. So linear time, constant space, and that's all I have for this one. It's late, so I am passing out, so that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I hope your fruits are in your basket. I got nothing. That's all I have. See you later. Bye bye.